There are 8.8 billion habitable planets in our galaxy alone. The Milky Way is teeming with Earth-like planets. They're similarly sized. They orbit stars, just like our Sun. They exist in the so-called Goldilocks zone. It's not too hot and not too cold for life. A 2013 study calculated the possible number of these planets. It concluded that there are about 8.8 billion of them. That's more than there are humans on Earth. The next step is to look for atmospheres on these planets. But if these planets are habitable, are they inhabited? If they are, why haven't we heard from them? In the Milky Way, about 1 in 5 stars resemble our Sun. They have the same size, color, and age. These stars have planets that are roughly Earth's size. The Kepler telescope peered at 42,000 stars. It examined just a tiny slice of our galaxy. Scientists then extrapolated the findings to the rest of the galaxy. The Milky Way has 200 billion stars. Around 40 billion of them are like our Sun. About 22% of these Sun-like stars have Earth-like planets. But the problem is, they're too far away. The closest Earth-sized planet is probably within 70 trillion miles of Earth. Some of these planets may even be better than Earth. A recent study identified a number of superhabitable planets. They're a little older and larger than Earth. They're also slightly warmer. They orbit stars that change slower than our Sun. 24 superhabitable planets have been identified so far. All of them are over 100 light-years away. The researchers searched among the 4,500 known exoplanets. The 24 planets they identified don't necessarily have life. They are just suitable for habitation. Our solar system's Sun has a lifespan of less than 10 billion years. It took life about 4 billion years to appear on Earth. So other similar suns must be at least as old. Otherwise, they may burn out before life evolves. Stars, such as our Sun, are known as G-type stars. There are also K-type stars, which are smaller and less luminous. K-type stars have lifespans up to 70 billion years. This means the planets orbiting them can be older. They've had more time for complex life to develop. But planets that are too old are also uninhabitable. Their geothermal heat is spent. They lack protective geomagnetic fields. About 1.5 of Earth's mass is considered ideal. A slightly larger planet would have more land. It would also have a stronger gravity. This would allow the planet to retain its atmosphere longer. Humidity and moisture are also very important. More moisture and slightly warmer temperatures would be good. A mean surface temperature of 8 degrees Fahrenheit greater than Earth is preferable. This would create greater biodiversity. None of the 24 planets meet all the ideal criteria, but at least one has 4 essential characteristics. Kepler 20b is known as super-Earth. It's 10 times more massive than our planet. It has a gravity 3 times stronger than ours. Stronger gravity fuels the erosion of mountains. Theoretically, their decay could create dozens of islands. Kepler 20b's surface would be flat compared to Earth. It would be the ideal place for biodiversity. There's just one problem. Kepler 20b has double the Earth's escape velocity, so leaving the super-Earth would be a challenge. Could that be why we still haven't heard from the Keplerians?